So what we're talking about is fragmentation, basically. So if we have the same idea of having a platter here, and we have some file we would probably assume to be written along something like this, just some sector in the hard drive and continuously written on some sector in the hard drive. It's not necessarily true, and you're not necessarily guaranteed that all of the data will be in one long continuous string on the hard drive. In fact, the computer will realize, okay, well, maybe I only have a third of the available space available here, like this. So this is 1/3 of my data, and then I have another third of it available here, and then I have another third available here. It will actually fragment this file, so-called, into 3 different locations on the hard drive. And so you might have heard of this process called defragmentation, where the theory is that fragmentation will actually cause your computer to slow down a bit, because in order for it to find all of the pieces for one individual file, will take it longer to jump from this location to this location to this location than it would if the entire file were located just in one continuous block on your computer. And that it certainly is true, especially with hard drives with spinning platters. It's not quite so much of a problem on SSD drives, but this is something that manufacturers have tried to battle by coming up with utilities called defragmentation utilities. And you might have run this on your Windows computer in the past, and basically what it does is it analyzes everything and will try to then make everything into a continuous block like it should be, and erase the previous blocks of data. And so the question then is, if this is in fact fragmented, and we actually run some software that tries to recover some individual files, then how do we know that the file starts here? If it's been deleted, if its references have been deleted off the file allocation table, and we don't know that it's been broken up into 3 parts, and we don't know where these 3 parts are located, how do we then know that the 3 parts are located at these specific regions on the disk? And the answer is that we don't, really. But we will get some junk data in between all of these fragmented pieces, but sometimes we might be able to tell if there's another file that's been started in the middle just based on its headers. So one of the things that we've been talking about with files is that they all have specific file formats. So like JPEG, for example, has its own specification. It has its own file format. A GIF file has its own specification and file formats. You can actually look up these specifications online and see the first few bytes that actually signify one of these types of files. And an actual bitmap file, for example, begins with some of the beginning bytes. The very beginning is something, the ASCII characters BMP, so that you can actually look for a known sequence of characters within these fragments. And if you find that exact sequence, like BMP existing in the first 4 or so bytes of the file itself, then you can say, you can be reasonably sure that this file might be then a bitmap file. So this is how we would then search the hard drive for one of these files. If we wanted to look for all of the JPEGs that have existed on our computer, for example, we would perhaps look up the specification for JPEG, find the bytes in that file that make it a JPEG file. There will be some known bytes at the very beginning of the file called the header of the file that specify that it is actually a JPEG file, and we will then search all of the sectors on our hard drive that match that header. When we found it, then we can be reasonably sure that we found the beginning, at least, of a JPEG file. And similarly, we will know that the footer of a file, the very end of a file, will probably end in some known sequence of bytes, so we can then search to the very end of that file and then consider that to be one JPEG file. And like we said before, we could actually have some bad data in between, especially if there's been some fragmentation, but that's just sort of the problem that can happen with fragmentation on a computer. Did I see a question? Yes?
How useful is defragmentation actually?
How useful is defragmentation actually? It's useful enough that Apple has decided to do it automatically on their macOS operating system, such that small files that it considers fragmented, it will actually delete those files off the hard drive and then write them elsewhere in a continuous block, just so that they are properly defragmented. Just anecdotally, when I used to use Windows many years ago, and I would defragment the machine after a long while of not doing it, there was actually a noticeable increase in performance, at least in reading files, just because the head, the so-called head, the piece of the hard drive that actually seeks across all of this data, which, as you probably recall from the hardware lectures, was just a little microscopic thing that floats very close above the platter of the head will actually, or rather over the platter itself, actually has to move to seek, to find all of these bits of information. And the more that it has to search, even for one file, the longer it will take for us to load or to write that file. So there is, in fact, a perceivable change. It just depends on how badly fragmented your hard drive happens to be.